All right, let's just jump right in. I want you to picture this for a second. Imagine 3 people crammed into a tiny metal can, hurtling through the absolute blackness of space. They are more than 200,000 miles away from Earth, from everyone. Their goal was the moon. But, as we know, they never made it.
That right there, that's the voice of astronaut Jack Swigert. And those are some of the most chillingly calm words ever spoken. Because what he's reporting is a complete catastrophe. There's been a massive bang that shook the whole ship. Alarms are blaring everywhere. And if they look out the window, they can literally see their oxygen, their life support just bleeding out into space. The mission to the moon? It's over. But the mission to get home, that's just started.
So, you have to ask, right? How does a mission that was supposed to be pretty routine suddenly become the single greatest survival story in the history of space travel? Well, what's so fascinating is that this story doesn't start with the explosion. No, it starts years before, with a series of tiny, hidden mistakes. We're going to unpack how they got into this mess, and more importantly, how they got out of it.
Okay, so to really get what happened up there, we've got to rewind. The thing that crippled Apollo 13, it wasn't just some random unlucky event, not at all. It was more like the final domino in a long line that had been set up for years, a hidden history of small errors that aligned in the worst possible way.
There's this concept called the Swiss cheese model, and it explains this perfectly. Think about it. You have all these layers of safety, right? And each layer is like a slice of Swiss cheese. It's got holes in it, little potential flaws. Usually it's fine because the holes don't line up. But what happens when, just by sheer bad luck, all the holes in all the slices line up perfectly? Well, you get a straight shot for disaster. And for Apollo 13, the holes were about to align. So let's follow the path through the cheese, shall we? It starts 2 years before the mission even launched. An oxygen tank gets dropped. Just 2 inches. I mean, who would even think twice about that? A tiny, harmless little bump. But that was hole number 1. Then, hole number 2. During a pre-flight test, a technician accidentally hooks it up to 65 volts of power instead of the normal 28. That surge of electricity just fries the internal safety switches, basically welding them shut. And here's the killer detail. That extra heat silently cooked the insulation off the wires inside. So now, you don't have an oxygen tank anymore. You have a bomb, just sitting there, waiting. So now, back in space, the main ship is dying. It's losing power, it's losing oxygen. The astronauts have only one choice. Get into the lunar lander, the Aquarius. This thing was never meant to be a lifeboat. It was designed to take 2 guys to the moon's surface for maybe 2 days. Now, it has to keep 3 men alive for 4 days, all the way back to Earth. And right away, the problems start piling up. Big problems.
The very first crisis, and maybe the most urgent, was the air itself. Every time they exhaled, they were pumping carbon dioxide into this tiny sealed cabin, and the CO2 levels were rising, fast. If they didn't get it under control, they would get headaches, become confused, and eventually just pass out and die. They were literally being poisoned by their own breath.
And this is where you get one of the most famous problems in engineering history. See, the dying command module had plenty of filters to clean the CO2 out of the air. The problem? They were square. The system in their lifeboat, the lunar module, it needed round filters. I'm not kidding. It was the ultimate square peg in a round hole problem. But with life or death stakes, they had the fix right there, but no way to plug it in.
So what do? Back on Earth, the engineers at Mission Control literally dumped a pile of stuff on a table, an exact copy of every random item the astronauts had with them. And look at this list. We're not talking about advanced space tools here. We're talking duct tape, cardboard from the cover of a flight manual, a sock. And with this junk, they had to invent a solution from scratch. And then they had to talk 3 exhausted, freezing guys through how to build it from 200,000 miles away. And they actually did it. They came up with this crazy, ugly-looking device that they nicknamed the mailbox. It was held together with nothing but duct tape and ingenuity. They talked the astronauts through building it, they plugged it in, and it worked. Against all odds, it worked. The CO2 levels started to fall. I mean, it's got to be one of the greatest MacGyver moments in all of human history. But look, fixing the air was just putting out one fire. The whole spacecraft was still a wreck, and they were staring down a whole cascade of other crises.
Just think about this for a second. They are 200,000 miles away. There is no rescue ship, no one is coming to get them. If they can't solve these problems themselves with what they have on board, that's it. They are completely and utterly alone.
And it was getting cold. I mean, freezing. With most of the power shut down to conserve energy, the heaters were off.
The temperature inside the cabin dropped to about 3 degrees Celsius, that's just above freezing. Water was literally condensing on the walls. They couldn't sleep, they were shivering constantly, and on top of all that, one of the astronauts, Fred Hayes, developed a raging fever from an infection.
And all the while, they're playing this terrifying game of resource management. The lifeboat was stocked for 2 guys for 2 days. They had to make the water, the oxygen, and the battery power last for 3 guys for almost 4 days. Every single decision, every flip of a switch could be the one that doomed them. The margin for error was basically 0.
So after 4 brutal, agonizing days, they finally see it, Earth. They're almost home, but the single most dangerous part of the entire mission is still ahead of them. Re-entry, that fiery plunge back through the atmosphere. And there was one massive, terrifying question that nobody, not on the ground, not in the capsule, had an answer to.
The heat shield, the thing on the bottom of the capsule that's supposed to protect them from burning up. Was it damaged in the initial explosion? Did the days of deep space cold cause it to crack? Nobody knew, and there was no way to check. If that shield failed, they would be vaporized in an instant. All they could do was brace themselves and hope. As they hit the atmosphere, this superheated plasma forms around the capsule, and it cuts off all communication. It's called radio blackout, and it's totally normal. But it's supposed to last a specific amount of time. On that day, the silence dragged on and on, for 6 seconds longer than it was supposed to. Imagine being in mission control. That extra 6 seconds must have felt like an eternity. The whole world was holding its breath, just waiting. And then, a voice. A crackle of static over the speakers. They made it. They were through the fire. Soon after, the parachutes blossomed in the sky. A perfect deployment. Against every single odd, they were home. Sure, they never made it to the moon, but what they had accomplished was, in its own way, even more incredible. NASA actually came up with the perfect term for it. A successful failure. It's such a brilliant contradiction, right? By every metric, the mission was a failure. They didn't land on the moon. But the act of getting those men home, the sheer human ingenuity and teamwork it took, that became one of NASA's most triumphant moments. It completely redefined what a successful mission could look like.
And the impact of Apollo 13 is just huge. I mean, it completely changed how NASA approached safety and crisis planning. It's still used as a textbook example in business schools on how to manage a disaster. But really, it's more than that, isn't it? It's a story that shows us what we're all made of when everything goes wrong. It's about what we can do when we just refuse to accept defeat.
You know, there's this one last, really poignant moment. Just before they re-entered the atmosphere, they had to jettison their lifeboat, the Aquarius. This little ship that had kept them alive for 4 days. And as it floated away, knowing it was about to burn up, Commander Jim Lovell got on the radio and said, "Farewell, Aquarius, and we thank you." Just a simple thank you to the machine that saved them.
And that really leaves us with one final question, doesn't it? This story is way more than just a cool space drama from 50 years ago. It's a masterclass in staying calm and being creative when you have nothing, and what a team can do when they have one single clear goal. It really makes you think, what can we all learn from a crisis that was solved with duct tape and cardboard when we face our own impossible problems today?